Welcome back. I'm Ms. Killen here at MPB, ready to dive into some more Algebra 1, getting ready for our average rate of change. We're looking at IF6 today, where I can determine average rate of change, also known as slope, over different intervals. So let's jump in and see what we've got. Okay, so it says let's use the following graph. Now, like we've learned previous lessons, always look at the graph, see the information that we can get. So I have a graph where it looks like I start at point J and it goes through point K with a curve. So that's something that we need to find interesting. And it says draw a line from J to K. So let's go ahead and do that. Do that on your notes page. Draw a line from J to K straight as possible. I can't draw a straight line, but that's okay. Now, what I want to do is I want to use my slope formula to solve for the slope of this interval J to K. Now, we have learned several lessons back how I solve for slope. I use my slope. I have to have 2 points, y2 minus y1 over x2 minus x1. Now, you're probably trying to remember, okay, Ms. Killen, where does those x's and y's come from? That's okay. I'm going to choose one of my points to be point 1 and one of my points to be point 2, so that's okay. So I'm going to have x1, y1, x2, y2. Now that I have figured out which point is what, I'm just going to plug those numbers into my formula. So let's go ahead and do that on the board. So I've got y2 minus y1 over x2 minus x1. Now we're just going to simply do the math. 4 minus 2 is 2. 3 minus 0 is 3. What does this mean? Well, we found the slope of 2 over 3, but what does this mean? It means that I am going to rise 2 units, and then I'm going to run 3 units. We use the same formula as slope to also find our average rate of change. The reason we're saying average rate of change is because this is not a linear function. All right, let's look at the next one. It says, let's do some practice. Keetra is jumping off a limb into the pond behind her house. The height of her jump can be represented or modeled by the quadratic function h of t equals negative 14t squared plus 14t plus 16. This shows the height over the water in feet, and the t is the time in seconds after she jumps off the limb. So we're looking at our graph, we're looking at points that we're given, we're getting all the information that we can about this graph. Then let's go to the question. It says, what is each interval's average rate of change? On the side, it says, consider the formula for average rate of change. Well, what did we know our average rate of change is just like? Correct. Slope. And we remember y2 minus y1 over x2 minus x1. Now, you are sitting there looking at your notes page, and you're looking at the board saying, but Ms. Killen, I have more than just 2 possible points. How am I going to figure these out? That's a good question. I am first going to get all of my coordinates for all of my points. So K's coordinates is 0, 16. I's coordinates is 1, 22. M's coordinates is 2, 16. And then B's coordinates is 3, 0. So now that we have all of our coordinates, now we can look at how to use this slope formula. I'm going to start labeling. I'm going to use this one as my x1 and my y1. This one is my x2 and my y2. The reason I'm using k and I first is because this is the first interval that it asked me for. So let's go ahead and do that math. So I've got y2, 22, minus y1, 16, over x2, which is 1, minus x1, which is 0. And then I simply do that math. If you need to, you can always plug it into your calculator in fraction form, and what do you get? I get 6/1. Good job. So now that we've found for the first one, let's go back and look at my second interval that it's asking me about. Now, I've already got my point I labeled with x2 and y2. So what I'm going to do is, since we're just using this right here, I'm going to label this one as my x1 and my y1. So let's go ahead and do them. Make my fraction and go ahead and plug in. y2, 22, minus y1, which is 16, over x2, which is 1, minus x1, which is 2. Plug that in to your calculator or simple math, and I'm going to get 6/-1. So my average rate of change for the interval I to m would be -6/1. Good job. I want you to do this next one by yourself. I'm going to do it on the board. You do it by yourself, and as soon as you get done, look up to see if your answer matches. Does yours match mine? -16/1? If it does, you've done it correctly. Now, every time that we find our average rate of change, sometimes we're going to get decimals, and that's okay because it tells us that we can round. Sometimes we're going to get decimals, and that's okay because we can round to the nearest tenth, or the problem may give us an exact amount to round to. So if you come up with a decimal, don't worry, because sometimes that's going to happen. There are decimals in math. And we noticed that our positive and negative slopes mean if we're increasing or if we're decreasing. Let's work some MDE map test practice questions. You knew it was coming. We're working on those. So, John C. at a local store ordered a shipment of video game systems. The store sells 30 systems weekly to customers. As a result, the number of systems in stock decreased to 190 in the first week. Which statements correctly interpret the rate of change or the y-intercept of the gaming situation? Select two answer choices. So I'm going to give you a minute. I'm going to let you read through the passage again, and then I'm going to let you look at the answers and see which ones you can come up with. All right, so we notice that at the beginning of our passage, it says that we sell 30 weekly. So that means if you sell something, are you increasing the amount or are you decreasing the amount that you would have in the store? You're right, you're decreasing. So what happens when I decrease numbers? It's either negative or subtraction. So it says there are 30 systems sold each week. That can be my answer because that is a true fact looking back at the passage. Now let's look at the other ones. It says there are 160 systems in the shipment. I don't know because it doesn't tell me how many come in shipments, just that we get shipments. There are 190 systems in the shipments. Then again, we do not know how many came in the shipments, so we can't say that. So let's look at D and E. The situation can be modeled by, I have y equals 30x minus 190, or 30 equals negative 30x plus 220. Now we set up here that when we decrease each week by 30, that has to be subtraction or negative. So that 30 would be negative. So my answer would be E. That's a good job going back to those passages to get that information, that's usually going to be the best help that we can get when we have these word problems. Good job. Let's look at the next ones. All right. Deasia is doing her homework. She has a problem that reads, the graph represents the temperature change over a period of time on a single day is below. Which unit would be appropriate for the rate of change in the graph? So let's read the graph and see what information we get first. So we're starting at this point right here, which is at 0:50, and we're going to this point down here, which would be at 6:30. So our line looks like it's decreasing, and when we look at, what did it call it? This temperature change over a period. So what would be the appropriate rate of change? So as I go down for my rate of change, I rise over run. So what is my rise measurements? Temperature over my run, which is my time. So what is my temperature measured in? It is measured in degrees, and what is my time measurement in? Hours. So my answer would be C. Good job looking at all that information. When we have these graphs that come from a passage, the passage is going to give you information about the graph. And then you've got to take that graph information and read it, knowing that we're reading a graph from left to right, to make sure that we can answer the questions properly. Good job. All right, let's look at the next one. So now it's time for you to master this. Go ahead and pause the video, work on this, and then when you and your partner or you by yourself get these done, come back and let's see what we got. All right, so let's look and see what we've got here. It says, use the calculator or Desmos to graph, then answer the question. So now that I've read the question, let's see what this passage tells me. It says, what is the average rate of change for the function f of x equals 3x squared minus 5 on the interval of -3 is less than or equal to x, which is less than or equal to -1. So let's go ahead and pull Desmos up and let's plug it in. So everybody go ahead and make sure that you plug this in. I had f of x, which is also known as y. And then I have 3x squared minus 5. So there is my graph that we see. Now it had an interval I need to look at. So let me go ahead and pull a table on this. Now, do we remember how to pull a table? I go to my gear and pull that table. And I am looking for -3 to -1. Well, I see the -1, but I don't see the -3. So what I'm going to do is I'm going to put in the -3, and it gives me my answer. So I've got -3 at 22, -1 at 2. So let's go back and put that into our problem. I've got -3, 22, and I've got -1, -2. So here are my 2 points. Now I'm going to look for that average rate of change. And how did we use that average rate of change? y2 minus y1 over x2 minus x1. I am going to label x1, y1, x2, y2, and plug in my numbers. -2 minus 22 over -1 minus -3. Go ahead and plug that into your calculator if you need to and see what you get. I'm going to do it in real time so we can see that I get exactly what you do. I have -2 minus 22, and I get a -24. And I have -1 minus a -3, and I get a +2. Now we have learned every time you get a fraction, you always reduce. So if I reduce negative 24 over 2, I would get a negative 12 over 1 to be my average rate of change. Awesome. Let's look at number 2. Consider the graph below. Determine the average rate of change between each set of intervals. Now, excuse me. I'm looking at interval M to A, then interval A to T, interval T to H, interval A to H, and then interval M to H. So I have loads of intervals I'm looking for. I have already got in my problem what each coordinates is. So all I'm doing now is plugging it into my problem. So let's go ahead and do that. Let's look at the first one. I'm going to have x1, y1, x2, y2. So I have 0 minus a negative 3, and I have 0 minus a negative 8. My answer, positive 3 over 8. You're probably sitting there going, Miss Killen, how'd you get a positive? They're negatives. That is true. But when I subtract a negative, we've learned that subtraction of a negative is just like addition. So let's look at our next one. So I've got A to T. Since I've already got this one as labeled 2, I'm going to label this one as 1 and go ahead and try this one. I've got A to T, so I have 0 minus 4, and I have 0 minus 3. I have a negative 4 over a negative 3, and a negative divided by a negative is going to give me a positive. Good job. All right, let's look at the next one. I've got T to H. So T to H, since I have my T as labeled 1, I'm going to label my H as 2 and go ahead and plug that in to my problem. So I have 6 minus 4 and 6 minus 3, and I'm going to get, what is it? Yes, 2 over 3, which is positive. And so let's look at A to H now. So A to H, I'm doing this one to this one. Now, Miss Killen, they're both labeled 2. That's all right, because the wonderful thing about these graphs is I can erase them. So I have x1 and y1. So let's go ahead and plug that into our problem. I've got 0 minus 6 and 0 minus 6. I have negative 6 over negative 6. When I have a negative over negative, that's a positive. And when I divide a number by itself, that is a 1. So I would have this as 1 over 1. Good job. Now, our last one is from M to H. So again, let's erase what we've put. And I'm going to have x2 and y2. And let's plug this into our problem. So I've got negative 3 minus 6 over negative 8 minus 6. You can plug that into your calculator. I'm going to do that. I'm going to put my fraction in and put negative 3 minus 6 in my numerator, negative 8 minus 6 in my denominator, and I get positive 9 over 14 because a negative divided by a negative is a positive. Good job. Let's not forget, average rate of change uses the same formula as slope. Intervals are notated by our brackets. We need to know that going further. What is on the y-axis goes on top of my slope fraction, and my x-axis goes on the bottom of my fraction. The calculator, Desmos, will help you with these intervals. That is the best tool that we have in our toolbox for answering these questions. Thank you for learning with us here at MPB. I'm so glad that you came. I'm Miss Killen, and thank you.